But after I complete this part 4, we'll have completed the foundation, fundamental, theoretical part. Then 5 will be mostly on problems, issues, and things that I have observed that I want to bring to your attention. And 6 will be a concluding remark. So we should go through in an hour this part. First, technology innovation capacity building options. There are 2 options. One is buy option, that is make option. The buy option is normally what we call technology transfer. From one enterprise, and please note, from one enterprise to another enterprise. Generally, we have a tendency in developing countries to think about the technology transfer is always from developed country to developing country. And also technology transfer means there's a donor in the developed country and there's a recipient in the developing country. I request you to please forget that forever. There's no donor in this world. Technology is only purchased. Technology is never given by anyone to anyone else. So buy option means technology transfer from one enterprise to another enterprise, and make option is technology development through, and this is the part that I'm going to discuss in more detail, through commercialization of research results. This is our own. This is what we do ourselves. And then just for your attention, I'm showing here the limitations of technology transfer, international technology transfer, the buy option. Technoware transfer is a business deal where price is determined by seller-buyer relative bargaining power. Okay? If you have got good bargaining power, you get a good price. But if you have very weak bargaining power, you get a lousy price. Humanware generally moves from poor workplace to high opportunity for growth workplaces. High opportunity for growth workplaces. Within the country, you find good humanware moves from an inferior enterprise to superior enterprise, where the opportunity for growth and development is very high. Same way from developing country to developed country. People move because the opportunities for growth is very high. So it is by nature. There's no, and it happens generally in favor of the developed environment. Infoware transfer usually takes place for free. This is the point, please note, for free, from developing to developed country enterprises. And we sometimes do not recognize this. We give away the infoware free without realizing that we are giving the most important component. And later on, I'll show you a cartoon to illustrate this point. Orgaware transfer may be free, but success depends on local work ethics and adequate adaptation. Because what is possible in Japan is not possible in Bangladesh, because the work ethics is quite different in 2 places. So we had to adapt it, because Orgaware is steps, procedures, group activities that we follow. So we have to adapt it for our conditions. And last one, SysNetWare transfer is held by ICT and cloud system providers for costly service contracts. But we have no choice, as long as now China has got its own SysNetWare, Alibaba, and all of those. But until we have those, we are dependent on Google, Facebook, and services which are provided by developed countries, and we have to pay for that. Finally, I make this remark, note, in globally competitive world, the buy and make option is available only for Technoware. So when you talk about technology transfer, we're basically talking about Technoware. And now I would like to remind you that where I made a slight remark to appropriateness when we talked about sustainable development, the appropriateness concept is only valid for Technoware. Why? Because every technology, remember I said it's human-made, help-made. Every technology is made at a place by people for a certain objective that they have, which matches with the resource endowments at that place. It's only when that technoware is moved from that place to another place, it may be appropriate or it may be inappropriate. If the requirements, resource endowments are the same, it's appropriate. But in most of the cases, they're not. So by nature, they're inappropriate. So I prefer to call appropriateness of technology rather than appropriate technology. And then you will forget about what Schumacher said, small is beautiful, that in developing countries, we do not have to have grassroots technology, labor-intensive technology, because you cannot use grassroots technology or labor-intensive technology to produce a product to compete in the global market. Please remember that. Now, these are the supporting activities for technology transfer as well as for technology development. Established mature goods in the established mature good industry, what are the things normally happens? We start assembling products from imported parts for lower end of the market. Then we manufacture some of the parts, but we still import core parts or under license. Then we start manufacturing some of these core parts ourselves. And finally, we produce our own design and we produce our own product. And this is what Minister Habibie of Indonesia used to call start at the end and step by step move to the beginning. Completely CKD brought in, only assemble, but eventually you have to move in. You have to move to development where you design your own product and get into your own production. Otherwise, you cannot compete in the world market. There are certain requirements here that I put down here. And note here again, for new technology-based industry, if you've got a large multinational enterprise in the country, then government does not have to do anything because they have their own factor creation mechanism and they do everything by themselves. Factor creation mechanism means creating the technology factors which enables you to compete. It's only for small and medium scale enterprises and that we need government help. And that's where we're going to talk about the incubators and other things that are very important. So for global market entry, local firms need national support system to succeed through business. Now let's look at the R&D commercialization process. There are two ways. New scientific knowledge push innovation versus new market pool technology concept innovation path. What happens here? Scientific knowledge, research and development, manufacturing, marketing. Here, marketing people comes out with a new product concept, research and development, manufacturing. So generally, R&D work focus for acquiring competitiveness in the globalized setting is external dependence reduction, reliance on independent decision, and global product creation. R&D work can be done by the firm that is in-house, which is make option, technology option. R&D work can also be done by contractual transaction, external, buy technology option. But even for buy option, in-house R&D work, including reverse engineering, is imperative for acquiring mastery. So here I'm trying to show the two aspects. When gradual incremental type of technology innovation, focus of national R&D efforts are mastering imported technology, adapting imported technology, acquiring design capability. Then you can move into focus on R&D efforts for radical and disruptive type of technologies because design capabilities to come up with a new product. So product innovation becomes focus here. Process innovation is focus here. So creating new products, product facilities, building differentiated marketing, product marketing. Concentration of R&D efforts for process innovation, concentration of R&D efforts for product innovation. Minimum R&D investment, generally small to medium R&D investment, moderate to high investment, very high R&D investment. So my final remark for process innovation, tech transfer is okay, but for product innovation, tech development is essential. Now let's relate that. What did we say for us to reduce our prosperity gap? We have to get into global value chain, and we have to become global companies. But how, what kind of product we have to sell? Technology intensive. What kind of industries we have to have? Technology industries, technology intensive. And technology transfer does not help to achieve that. We can get started, but eventually we have to get into our own technology development. Here I want to repeat this what I said, because this is something very important for us to remember, that innovation happens following an S-curve pattern, generally, in every case. In the beginning, after takeoff, increasingly, then there is an inflection point, and then decreasingly, and then starts to decline. But fortunately, one technology can have this S-curve, but another technology comes into the market. So here I'm trying to show oldest technology S-curve, intermediate technology S-curve, and latest technology S-curve. And when we have this situation, then it becomes very clear that if you try, see here, when you have got a single S-curve and somebody is running, somebody is walking, we can run to catch up. So the catch-up situation comes only when the changes are happening in the single S-curve or current S-curve. But when you are having a situation where there are multiple S-curves and technologies are changing disruptively, then the strategy is leapfrogging. In other words, skip some of the intermediate stages and move there. And I just put a reminder here, incremental innovation, learning focused process innovation. Disruptive innovation here on the other side, R&D, creativity focused product innovation. And at the bottom, this is a general picture of what are the things that we have to do from relentless product innovation and process innovation, following one after the other. Now, I want to spend a lot of time on the incubator, because that is the central focus for commercialization of research results. This is the National Technology Innovation System, comprising integrated intermediate agencies that serve as linked infrastructure for the generation, production, application, and diffusion of locally made techno innovations. This is not for technology transfer. This is for locally made techno improvements for local enterprises, which eventually will go to become global enterprises or join the global value chain. So what are the elements? Three major elements here. Academic, science, and technology institutions, here on the left-hand side, here. Public and private research and development entities, and then government, goods and services producing enterprises. This is the three institutions, entities, which have to be linked. Concepts are developed here, industrial design comes here, generic devices are produced here, special artifacts are produced here, and then here, value-related problems, cutting-edge ideas. But at the center, I have the incubator. But before I talk about the incubator, let me complete the system, the linked infrastructure. What are the things that surrounding it? Intellectual Property Regulation Agency, Information Services Agency, knowledge profession associations, venture capital financing, design and tool engineering, standards and certification agencies. But please note, these institutions exist in developing countries, but mostly they do not have the minimum critical mass. And I'll explain that in more detail. Institutions generally, these institutions, isolated from another, and therefore they remain inactive. In the developed countries, market mechanism is the driver for linkages. In the developing countries, because the market mechanism is not such that you have these automatic linkages, government has a role to play to make sure that these linkages are effective and we can commercialize research results through the incubators that I'm going to discuss in more detail. This is the incubator. Remember, now I'm adding the government also. Research-1 universities, government organizations, state-of-the-art laboratories, private SME enterprises. Research universities, and here I would like you to note that I put Research-1 universities deliberately to point out that in many of our countries, we set up a science park next to an undergraduate degree offering university and hope that we will get research results commercialized. But here for us, I'd like to take a few minutes for all of us to think a little bit more seriously. Incubator, the word incubator. What does incubator mean? It came from the hatching of chicks from egg. Now, can you hatch anything if you do not have the egg? Obviously, no. So we have some time, we set up science parks, which are supposed to work as an incubator, but there's no university which is producing the egg that you're going to hatch in the incubator. There's a failure by design. So please remember that. And that's why I put Research-1 university means universities with laboratories and doctoral degree programs where new product ideas are developed. Next, state-of-the-art laboratory. Right? New solutions developers. Here, new concept developers. Research-1 university. SMEs, new product launchers. And then government, new project promoters or technical advisors. But please note some of the qualifiers that I put in here. This is the science and technology sector here. This is the research and development sector that we normally know. This is the goods and services sector that we normally know. And this is the government, but please note the terms I have used here. Regulation and facilitation sector. Some people think that government's role is to control. No. If you want R&D results commercialization, government has to perform a facilitating role. But of course, there's the regulation in terms of quality, in terms of many other requirements. They regulate. But most important is facilitate. And in the incubator, please note that instead of only putting the incubator, I have put the other one, which is most important, because without this one, startup business, the incubator results again will remain in the shelf. Nothing happens. So you have the incubator where product innovation, process innovation are done, but that should lead to startup business enterprises. And again, I'm repeating the crippling shortcomings in our developing countries. University centers of excellence, core areas, and state-of-the-art research and lab expertise have utter mismatch. There are some Research-1 universities in our countries, but their expertise, and there are some laboratories we have, but their expertise areas are not matching. So if they're not matching, you do not get what you want. And then finally, absence of legally bound agreement for collaboration And this one I'm going to explain a little bit more. We have meetings in most of our countries. I have attended myself, many meetings between the universities and the private sector or R&D institutions in the private sector saying that we must cooperate, we must collaborate. But if we do not have any legal agreement, nothing gets beyond that statement. One more time, showing the incubator essentials. Look on the left-hand side, the ideas. Who creates the ideas? Generation of new ideas by university academic research. This is the R1 universities. Generation of new ideas by enterprise customer survey. Some of the private sector enterprises, their salespeople come up with good customer survey of what the customer wants, the need, which may sell. So these are the ideas. But on the right-hand side, smart, daring, energetic, do-it entrepreneurial action persons and the startup business. These are the real risk takers. These are the individual thinkers. And this is the incubation process in the middle. Design, lab research, lab development, scale-up operation. And this is always a teamwork. Here, individual. Here, also individual. But this is the teamwork where you have to get things done. And I try to say the same thing again here below to make it a little bit more explicit. Now, one more thing I want to point out, that it's very common nowadays. People use a lot of fancy terms to explain things, which makes it rather more difficult than what should be done. And one such thing was triple helix. You will hear people talk about triple helix. We have to have triple helix for development of local commercialization of local R&D results. So here's the triple helix I'm trying to explain. Substantial connectivity among three distinctive types of organizations, which include both public and private institutions legally linked to promote startup business ventures for economic development. I'm emphasizing the word legally. And you see here on the left-hand side also, I put that legally bound together. What are the things legally bound together? 1, 2, 3. 1 is the government, 2 is the academia, 3 is the industry. Common, a triple helix integrated landscape to promote startups are S&T parks, intellectual property creation and protection, technology transfer offices, and then here, incubator, accelerator, venture funding, and startup. But the most important is this. We have to remember, if they are not legally bound, you do not move from the egg to the product that we want to sell. Not only that, we want to compete in the global market. Okay, now I move to the next one. There's a lot of discussion about innovation. S&T Park, innovation hotspot, innovation societies, innovation cities, things like that. So I tried to put all of them together. What are the elements of the innovation hotspot? Where or what do you need to have commercialization of research results, innovation take place? 4 important elements. Some of these we have discussed already. World-class R&D institution, world-class research university, and then I'm bringing 2 more terms which you are familiar with, but let's repeat. Related industry cluster. This related industry cluster was brought forward by Michael Porter, who talked about the relative industry cluster in Germany and some other places. But what is very important is that if you have a related industry cluster, then government does not have to do anything, because these industries together, they develop their own factor creation mechanism. What do? They create their own university. They create their own R&D institution, so that for those particular products that they need, they do not have to go anywhere else. So related industry cluster. And then, most important factor, of course, you do not get anything done unless you have this facilities for mingling of people. Many times people forget that. We set up the institutions, we do everything, but one thing is missing. What is missing? There's no place where people meet. If you have these three institutions in isolated silos, nothing happens. But what kind of mingling places? These are eateries, recreational sporting facilities that bring professionals close contact for invisible fusion of critical knowledge, tacit knowledge. Explicit knowledge is available in the literature. One can read, one can find, but it is a tacit knowledge, which is very important for creativity, for innovation, and for getting a new product out. And that happens only. And I'll give you a very interesting example. Sometime, suppose you are in one of those and you went to your coffee club, or you went to your nightclub to have a drink, and you found a member from another organization who was sitting there, was drinking, and he was very unhappy. You know him personally. You say, hey, John, what happened? Oh, don't tell me. I spent 5 years working on this project. We probably spent more than $5 million, found out it doesn't work. Can you imagine the value of that information? That is very important, that if you are doing something on that, leave it immediately, go do something else. Plus, if somebody says something of interest, you can get that idea and get your work focused in that direction. All right, innovation hotspots. Now, these are the three things that at the bottom I'm trying to show, that technology incubators operate at the core of research areas and zone triangles. And what is the research area triangle? Academic R&D units, we do basic research. Independent R&D units, we do applied research. Corporate R&D units, we do development research. And then here, research zone, interest zone, knowledge push and market pull, interest here, public-private interest here, and interdisciplinary scientific areas now, the fusion point. So this is something that we have to keep in our mind. That covered my part 4. Now I'm getting into the implications of what we have said and what lessons I have learned. And there's a lot of text here, and I'll try to cover the material in 20-25 minutes. First one is a little bit philosophical. In all the developing countries, we find now that we try to get out of our vicious circle of degradation and get on the virtuous spiral of hope. The hope that we talked about, making our enterprises become members of the global value chain and becoming global industries. Some of our enterprises becoming global industries. So here, this is our interest. This one you can look through. We have technology, innovation, climate, culture as the bottom, bedrock, on which the STEM education is based. S&T and R&D infrastructure building. Incubation, we talked about those, and I'm going to repeat again one more time. Intellectual property protection, competitive goods production and service provision, which will ultimately lead to sustainable economic development through industries, globalization. Now, based on what I have said already, it may become obvious to you that there are two things that we have to do in developing countries. One is the smart choice. We become world leader in selective goods and services. And there we try to catch up, because we have got here selective, traditional, established industries that inherently require proportionately less techno-aware assets and superior human-aware assets for manufacturing. We have an edge. So let's go for those. But that's not enough. We have to get into the emerging global digital industry, and that should be one of our top priority. Selecting emerging industry 4.0 type inherently requiring available artificial intelligence integrated techno-aware assets and highly trained human assets for manufacturing. That will help us to catch up and leapfrog for reducing our prosperity gap. Now, a lot of reading, but I'm going to highlight the most important one because this text is available to you and you can read it yourself because everyone has a copy of all pages of my document. So here I'm talking about the predicaments. What are the problems? What are the issues that we face in our developing countries based on some of the things that I have already mentioned to you already? Let's take first common predicaments regarding generation of fertile new ideas. Remember, we need to have the eggs to take to the incubator. So what are the common problems here? Limited number of research-one universities with negligible number of high potential ideas produced for commercialization incubators. This is a common phenomenon in most of our developing countries, very limited. Next one, our universities attempt to become centers of excellence in numerous areas with very limited resources. We have very limited fund, but we want to become center of excellence. Suppose we've got 5 faculties, each one wants to become the world famous in the world, but we do not have that much resources. That's another problem. Due to lack of resources, actual research activity are determined by external funding sources' interest. This is another problem you find. In most of our developing countries, our best universities are staffed by people who got PhDs from developed countries, and they, because of their latest PhD education, training, they try to draw international funding to continue the research that they have done before. Frontier knowledge specialization areas are have inadequate faculty numbers. Sometimes we have departments with 1 faculty member. But we all know that in order to have a very good research activity, you need few people. That's why I said the minimum critical mass is missing. Then academic programs emphasize only knowing, but almost no doing. This is something that I learned from my guru, Dr. Che, who told me, and I always remember, that this has been our problem, and this is still a problem in most of our developing countries, where our academic programs emphasize a lot on knowing. Our people know everything. But because they did not get the training, they're not able to do most of the thing that is necessary to produce a new product. Very critical comment. Now let me come to the generation of new ideas. This is the predicaments of new ideas from the enterprise side. Here, private enterprises do not have any market pressure for developing competitiveness. You all know that. Private SMEs do not have necessary financial resources for product innovation. Yes. Private sector enterprises do not try to join the global value chain and become global enterprise because they keep on focusing on technoware buy, but they do not go for make technoware. Even for buying, private enterprises are not in a good position to have a good bargaining position with the TNCs. The S&T parks that we have in our countries are mostly utilized by multinational companies for tax benefit purposes. Now let's come to the government. Common predicaments as far as the government facilitation is concerned. Collaborations are managed through high-powered council of committees with inactive ex-officio members. The committees have, who are the members? Very high level. sometimes ministers, sometimes secretaries. They're ex officio members. How often they meet? Not very often. And after they meet, there's some paper report, and that's the end of it. Nothing gets done. Established, and most of the countries, we're talking about regional industry cluster formation, which is simply an employment generation goal. Because instead of having all the industries in a central location, you distribute them to different places. But please try to understand that the concept of related industry cluster is quite different than this regional clustering of industries. Here you get employment generation distributed throughout the country, but related industry cluster is important for factor creation, where they will have their own university, own R&D institution to produce new ideas, new products. Public sector R&D institutions, R&D institutional reforms by simply changing names generally end up as lip service. Now, this one I can give you many examples, but better not. What I've said, in simple words, I can say that in most of our countries, now I'll explain that a little bit later, where it will be more appropriate. We lack of realization of the purpose of public sector R&D investment is indeed to foster R&D work by private sector. This is something that we also do not understand. The role of a private sector, remember I mentioned in the very beginning, facilitating role. If the public sector R&D institution funded by government has to be a facilitator, facilitate what? It should encourage private sector to get into R&D. If they can achieve that, they've done their job. They do not have to be the R&D results producer. Main job is facilitation. Okay, now if I come down here quickly, common predicaments regarding national innovation system infrastructure. Elements of national system infrastructure in terms of institutions do exist in most developing countries, but there's lack of very little critical focus, diffused. We do almost similar things in every country with limited fund. Most R&D institutions do not have, R&D and S&D institutions do not have minimum critical mass. And here, okay, there's two you can read for now, and I will explain this a little bit more in the next chart. But before I go to those predicaments, I want to get back to the incubator part one more time, because we have to make sure that we understand the incubator in totality. The actions and the culture, the mechanics and the culture. Mechanics is research, development, and deployment. The culture is commitment and collaboration for R&D commercialization success. We need both. And for mechanization or for the mechanics, this is the, again, knowledge, big data, universities, bright idea coming from there. Laboratories, professionals on this side, R&D equipment. Goods and services producers here. And then government, facilitation. So this is the totality. And I would request everyone to look at it in totality and then relate with the things that we have in our national innovation system. Now, I would like also to answer one question that I always get before you ask me that question, that many countries in our part of the world try to use the South Korean model for technology-based development. Even the model that I presented here for my presentation is primarily the South Korean model. What is the model? Effective industrial technology innovation management to achieve competitive advantage in selected industries, to make national enterprises be global players, leading to sustainable development in globally connected economies. But this roadmap has a difficult terrain for replication by developing countries. Why the difficulty? In short, we focus too much on the mechanics and we fail to address the cultural element, innovation culture element. And because we don't do that, we do not get much success. And I have summarized some of the lessons that I have learned, we have learned, Ramanathan there, Nazrul there, I see them together. We have learned these lessons from our experience in many Asian developing countries, which you can read. But I'm going to focus on only two parts here, the KIST and the Ministry of Science and Technology. What lessons we have learned about these two? Now, because KIST has been very successful, so every country still trying to have something equivalent to KIST. But there are three major reasons why I think we failed. The Korean Institute of Science and Technology KIST replication remained problematic due to three reasons I point out here. Not ensuring that the private sector enterprise funded R&D activities are kept secret. This is one thing we do not understand. We have a feeling that publicly funded enterprises should be open to everybody. But you cannot use a publicly funded R&D institution to do R&D for a private sector and tell everybody what we are doing for company XYZ. They will not give any fund to do that. Number two, not selecting high potential country advantage areas for R&D. We try to do everything. Korea, South Korea, even when KIST was established, they did a very extensive survey of what are their needs and what are the opportunities, and selected only 7 areas to get involved, not everything on earth. And even in those areas, they selected sub-elements very carefully. And then finally, using the academic criteria of rewarding publications. For a few minutes, I would like to request you, those of you who work in R&D institutions in developing countries, you know that the staff members of the R&D institutions in developing countries get promoted in a similar fashion as in the academic institutions. From junior scientific officer to senior scientific officer to principal scientific officer, like we get promoted from assistant professor to associate professor to professor based on publications. Now, what happens if you give people promoted on the basis of publications? Then that's what they focus on. They do not work to get money from the private sector to do research. They write papers, get published, and get promoted. That's very important for us to remember. Next, let me talk about the Ministry of Science and Technology. Almost every country now has got a Ministry of Science and Technology. But our Ministry of Science and Technology is not working the same way as the Ministry of Science and Technology originally in South Korea did when that was established in early 70s. Of course, the situation is different. And that's why you have to understand this point very, very clearly, why our Ministry of Science and Technology cannot function the way the South Korean Ministry of Science and Technology did. Number one, appointment of weaker and youngest minister. Who is this SAT minister in our countries? You will find, in general, a new, very weak, young person appointed as this science and technology minister. Can you expect that that minister can influence? Because as we said a few minutes ago, you need research commercialization. For research commercialization, you need academic institution, R&D institution, private sector, and all these people to work together. Can you make that possible by having the youngest and weakest Minister of Science and Technology? There's also large power distance in coalition government. In most nowadays, somehow we have coalition government, and the Minister of Science and Technology goes to the weakest partner of the coalition government. Again, another weakness. And finally, expectation of Superman achiever without direct blessing of the head of the state. In South Korea, if you ask me my personal opinion, why KIST was successful? Because KIST had 100% support from the president of the country. In fact, Dr. Che used to tell me that his name is Minister for Science and Technology, but he is the secretary for the Ministry of Science and Technology. The real minister is the president himself. That is very important. That's what gives the commitment. Now, sorry. Here, this one is, I'm giving you to look through very carefully later on, because we want creative innovation culture. I mentioned that. For that, what is necessary is professionals feel free to share ideas, opinions, and criticism. Professionals understand the risk and reward structure. Professionals believe in continuous improvement, and managers are committed to self-reliance. This is a very important point. And I cannot help to repeat this. You cannot expect external assistance to compete with them. This is a very common sense matter. Nobody is going to help us to develop our enterprises which can compete with their enterprises. So self-reliance should be the most important requirement. Now, this part is again repeating the things that I have already covered. So I'll say quickly, fundamental recognitions. As people are creative and they like to compete, technology innovation is in perpetual motion. Now you see I'm repeating things that I have said before to make everything come home, thereby contributing to intensification of globalization in the current innovation economy order. All entrepreneurs attempts to achieve sustainable economic growth through product process innovations that can bestow global competitive advantage. Then we need to look into the technology component sophistication, productivity gain, and market growth. We've talked about that. And enterprises acquire goods and services innovation through commercialization of R&D results in incubators that are legally joined work facilities, bringing together professionals from 4 NTIS infrastructure units: research universities, R&D institutions, goods and services providing enterprises, and government, regulatory, and facilitating agencies for both product and process innovation. And these are the constraints that we need to mitigate. Creativity promoting STEM concentrated higher education institutions that emphasize doing over knowing by combining state-of-the-art knowledge acquisition with interdisciplinary scientific laboratory-based practical research programs of world-class PhD level for selective, high potential product process innovation. Cutting-edge research and development activities performing in the advanced academic institutions, as well as public and private R&D institutions, have to be state-of-the-art level, frontier knowledge-driven in carefully selected priority areas followed in the STEM PhD education program. Establish incubators as legal entities, not just verbally agreed with no joint investment for joint returns. This is the most important point. Joint investment, legally bound joint investment for joint returns. Provide support facilities for tool building and designing, prototype building, testing, and startup unit development. Provide the most important ingredient of S&T Park and Technology Transfer Office, which is IPR protection service. Overcome chronic problems with the agencies: lack of minimum critical mass, lack of legal linkages, shortage of venture financing, avoid leave service of organization returns. And then here, finally, the commitments that we have to ensure. Wholehearted commitment at every level. enterprise, industry, and nation for winning the future through innovation. Nationally supported innovation project selection areas based on global insight, global foresight, opportunities and threats, and national insight, strengths and weaknesses studies by knowledgeable national professionals. Mandatory application of transparent decision-making criteria function having these four factors: innovativeness, attractiveness, competitiveness, and responsiveness. I'll explain that a little bit more a little bit later. Regulatory oversight for intellectual property rights, fiscal financial incentives for procurement contracts, and promoting a culture that demands total commitment for continuous improvement. And finally, self-reliance with self-confidence. That is very important. Now, this one I'm not going to look through. This is a summary of everything that I had before, putting together the national policies, policy goals, prerequisites that you can look through. There's nothing new in here. Having covered that, I'm now coming to the concluding part where I will recall some of the concepts and try to reinforce some of the ideas which are very important. Most important of these is for us to remember earlier days successful models. This one, earlier days successful models of other countries or other enterprises are generally not useful due to change in the situation. However, many core concepts representing the successes may be valuable. And here I'm giving you some examples which I have learned from the Korean cases and which I think may be useful for us and for you to consider. What are those? Make some and buy some technology strategy. Remembering that innovation is a teamwork of knowledge, industry, research, and government sectors. Remembering data to intelligent derivation. Data giving meaning becomes information, giving context becomes knowledge, giving insight becomes intelligence. And intelligence is actionable knowledge. And then here, for developing countries, we have to start with innovation, not invention. Why? Because invention is spending more money to get knowledge. But innovation is from ideas, we get money. So the science, you may ask this question. Invention, scientific discovery, science. For the time being, let's use the science that is available because we do not have enough resources to do that. And science is also available globally. But we have to focus on innovation where we move from idea to making money. And for that purpose here, turning ideas into value through creative innovation to join global value chain and global corporations. Keeping in mind, professional hard work with self-help mindset, leveraging innovation for competitive advantage. And the last one I put for your kind consideration, that let us remember, no aid. Aid cannot help us to become competitive. So this is the motto, and I would like to repeat I'd like to repeat, I'm looking for the word, to summarize what I wanted to say so far. Technological innovation is the master key for turning new ideas into cash through business by acquiring global market competitiveness. So I call technology is a game for the rich, a dream for the poor, and a key for the wise. Technological innovation is the master key for sustainable economic development through industry's globalization in the current competitive world setting. Repeating again here. Innovation, turning ideas into cash by global product marketing. Ideas, but remember, in selected goods and services, building global presence, strong business outcome, cash. That's our goal. And these are the things that I have tried to cover in terms of the goods production services provision function, primary function, technology component sophistication, capabilities accumulation, competencies elevation, and strategy progression. For supporting function, here we use the dominant factor to get advantage, enterprise resources management, enterprise quality assurance management, supply chain management, and enterprise excellence management. We need both technology transfer and technology development. So I'm repeating here, we start with technology transfer because that's the real world. If we do not do it, total failure. Because we want leverage innovation for competitive advantage to get to global business. The technology transfer and technology development. But remember, we have to get to new wow products in high-tech areas. So I put at the bottom here, we have to improve productivity to make the performance better, to reduce cost, add value, global competitive edge. And remember this most important thing here, R&D investment is necessary for both technology transfer and technology development options. For technology transfer, relatively small R&D investment is necessary for digestion of imported technologies, and at the same time, learning for technology development that calls for robust and substantial R&D investment. Moreover, technology transfer can be maybe good enough for process innovation, enabling catching up, but without technology development for product innovation, leapfrogging is quite impossible. And here, I mentioned to you the advantage of looking at our technology system components taxonomy. And I show you here at the bottom first. Look at this cartoon. Technology system components taxonomy, an appreciation that relative dominance of technology components utilized in any specific goods producing or service producing enterprise is uniquely determined. Developing countries with high quality and quantity of humanware have significant advantage over developed countries where same type of manpower cost is very high. And here we know the technoware transfer, this poor farmer is buying, this is symbolic, a computer hardware using foreign currency, but this person is keeping the facts behind. Though non-state-of-the-art technoware is sold in the global market, critical infoware is closely guarded for bargaining power or for selling at premium prices. And another point here is if you have good quality, good caliber humanware, then we can go to some of these new 4.0 type of industries, particularly system integration firms and professional services firms. These are hardware system integrators, and these are software application integrators. And many developing countries, you can find India, China, good examples of getting into the software application integrators. And South Korea and Japan are hardware system integrators now. And this is the scorecard, balanced scorecard I mentioned about. These are the 4 factors: innovation, innovativeness dimension, competitiveness dimension, attractiveness dimension, responsiveness dimension. So all of our innovation projects, we can assess the funding requirements and progress and continuity using this measure and drawing a polar chart like this, We do not have to use mathematics. I just put it up here because it's very complicated. You can use this visual chart to get an idea of where you stand and where you have to make improvements. Few more remarks. This is something that I think we can learn from the Chinese experience. The word crisis in Chinese have got two parts, danger. So in every crisis, there's both a danger and opportunity. And from the Japanese, kaizen, make better, change for good. So I put together here, leapfrogging opportunity in crisis, disruptive change type product innovation, and catching up opportunity in kaizen, gradual change type process innovation. And of course, I have to mention this because some of you may say that I'm talking about only financial prosperity. Money is not everything. Yes, I recognize that. Nothing can buy happiness, but I think money can buy everything else. This is something that I have learned from Dr. Che, and I would like to share with you for you to think. Instead of blindly following the successful models of other countries or other enterprises, developing countries have to rely on the adaptation of proven and clearly useful concepts to the current problem setting. Adaptive, and this is also very important, adaptive implementation of a crude plan is undeniably much better than endless bickering for the preparation of a comprehensive grand plan that is never wholeheartedly accepted by all and thus usually remains unimplemented. And my last slide. We know both of these people. Professor Yunus, Nobel laureate, from his saying, because he told us very openly that banks, and I started this morning by saying that even Bill Gates and Steve Jobs do not go to the bank to get money. Banks get money from them. So Professor Yunus told us banks do not give money to those who need money. If I generalize, what does it mean? Currently established global systems only help those already well established. And then let's learn from what Singapore Prime Minister Lee Kuan Yew said. If you only follow someone else's footsteps, you will always be behind. So industrial technology innovation management for prosperity. That's what I've been talking about so far. In the wow tech era, because that's what we are in now, calls for self-reliance as a virtue. That's it. Now I'm going to get out of my file share. Mr. Moderator, shall I get out my file share?
Yes, sure, sir.
Okay.
And we have turned on the permission for all participants. If they have any questions, they can ask before you conclude, sir.
Yeah, they can ask. Best thing is let them ask to chat box, and then you, because if everybody starts talking simultaneously, I'll have a problem.
Exactly. So in that case, we can allow them for writing in the chat box. I will read.
Yes, write in the chat box, and then you can bring those for me, and I will try to answer to the best of my ability. And also please note that for some of you it's getting late, but for me, fortunately, it's daytime, so I can stay on as long as you need.
So we have got a question from Shahriar Khan Russell. Sir asked about basically two questions. The first question is it a researcher's duty to make his or her research industrialize? And the second question is, if not, then whose duty is to do this? Sir, have you got my reading?
Yeah, okay. First, let me try to see whether I understood the question clearly or not.
Okay, sir.
Whose responsibility is it for the researcher to make sure that they do research for product development or for the private sector? That was the question, right?
Exactly, sir.
Okay. Now, I would not, I would, rather than saying whose responsibility, I would explain that again in the way I did before. It is because of the system. The researchers who are working in the research institutions, they are tied to a appointment system, promotion system where they can move up, they get advantage if they publish papers. So that is the problem. If they change it, and I understand, I can see Wati Hermawati here from Indonesia, I understand that they have changed the system. But earlier I found in most of our countries, we still follow, for our research institutes, we still follow this system of promoting our people on the basis of number of papers published. Now, the two reasons why I think it is not desirable, because if you change the system so that the researchers will be promoted on the basis of projects they bring in from the private sector, and the research institution is also private, they are not going to divulge the information to other people, then things will improve automatically. The other question that I want to bring to your attention is that you have to understand why I talk a lot about private sector. R&D is important. And most of the countries learned about the importance of R&D long time ago, in the 70s. Even UNIDO organized meetings, global meetings, where they pointed out that it is important for developing countries to spend money for R&D. And they proposed in those days, 1% of the GDP of the developing countries should be spent for R&D work. Now, just if you take the 1%, I will first of all say that most of the developing countries, we still do not spend 1%. It's 0.2%, 0.3%. But relate that 0.2%, 0.3% with our small GDP. What is the total value we get? Very small amount. Now compare that with the developed country situation. Most of the developed countries spend 2% to 3% of their GDP for R&D. 3% of GDP of United States, can you imagine the number? It's huge. Then one more factor that you have to consider is that in the developed countries, the R&D expenditure is done 75% by the private sector. Only 25% public sector, and the public sector goes for long-range science development. So most of the R&D work in the developing countries, which goes for product development, new product development, new businesses, new industries, are in the private sector. So that's the reason why I emphasized that we should also try, and that's the role of the government, to make our business, our research institutions private-oriented, and then make our private enterprises realize that they have to spend money for R&D also. I hope I have given the answer.
So thank you for answering the question, sir. What I have understood from you that it is a combined responsibility, right, sir?
I didn't want to put it that way.
Right, right.
It will become a responsibility only if you change the employment arrangement of the research people. At the present situation, the employment agreement is such that it's not going to make them responsible for private sector R&D.
Thank you, sir. We have got another question from Mr. Monish Shobhan, sir. He asked about from where we can have access the knowledge-based consultation from abroad, or is there any organization for optimizing business operations through information technological advantages? Because in Bangladesh, having advanced technology is expensive, and most of the time our business operations is backdated. So, sir, is there any way to get this information from international organizations or from abroad regarding related to advanced technology? Since in Bangladesh, it is not available in most of the cases.
I think I have answered that question in many, many different ways already. You cannot, this is my humble answer to you. You cannot expect outsiders to give you the latest technology to compete. They may give you the information, or you may hire. You see, you are talking about consultant. Michael Porter, you can hire Michael Porter for $1 million. He will come for 1 week and tell you a lot of things, what is to be done. And I know many developing countries did get this high power international consultants. And Michael Porter will come there and tell you, related industry cluster is very important. Please formulate one. Then how? That they will not tell. Okay, so please, I hope you'll understand that you try to get as much information as you can. And the best way I thought you can get information is from your counterpart who are working abroad. They can provide you sometimes some of this information. That's how KIST, Korean Institute of Science and Technology, was created in the very beginning. 7 Koreans working abroad with PhDs and 10 years R&D experience were brought back to Seoul to work in KIST, who knew, because when you bring people, they come with their grade. Because many of these are tacit knowledge, right? And they have the connection, and they can get some of those and modify for their own use. That's the best answer I could give and think.
Thank you for the answer, sir, again. And definitely, yes, as you told us that the entire session was a kind of a way out. How can we deal with these questions and answers and reality? So right now we have with us respected CEO of Daffodil Family, Mr. Mohammad Nur Zaman. Sir will be concluding and giving vote of thanks to everyone on behalf of the organizers of this conference. Sir.
Muted.
I guess, sir, we cannot hear you.
Yeah.
Yeah.
Is it okay now?
Okay now, sir.
Yeah.
Absolutely.
Thank you so much, Mr. Azaz, for inviting me to give the concluding remarks. And thank you very much to our renowned professor, Professor Dr. Nawaz Sharif, who has been delivering this most important and time-befitting topic for a long time. And I must convey my gratitude to the participants. Almost 70 participants joined today's session. And it's not only a number of 70 in terms of level of the participants, those who are very learned, about very top level participants attended this today's session. And thank you all. I would like to give a very short brief because it's now 9:30 almost. We have been passing almost 2 hours, almost close to 3 hours. The title today is Industrial Technology Innovation Management for Sustainable Economic Development of Bangladesh. If I just segmentize this title, first of all, I'd like to pick the innovation. That is, there is no other than innovation for any sort of development, either organizational or maybe national. And then come to the technology innovation. That is also a must. And then industrial technology innovation. And after that, industrial technology innovation management. It's then long after this. After 4 terms, there is a management of innovation, and which is technological and industrial technology innovation. So first, if I see the scenario of the third world countries, still we are in the level of innovation, which is a buzzword in this economy in third world countries. So a lot of times we are uttered about the innovation. So we are doing a lot of things on innovation, but nothing is happening actually. Not nothing is happening. There is definitely something is happening, but as Professor Nawaz said, the title itself, Industrial Technology Innovation and then Management. If there is so many innovation, then it comes for the management. But as Professor Nawaz sir said, the research and development, we have research, but probably there is no development. As he said in the university, the promotion criteria is to how many papers are produced. We are not saying about the outcome or its commercialization. That is very important. So we have to change the promotion criteria. One gentleman asked a question, is it the responsibility of the academician for commercialization? And another question was, who is the responsible for that? Very interesting and very important question. And the answer has been given, it's the system. Nobody is responsible. The responsible is to develop a system that only producing papers should not be the criteria of promotion. So that's it. If we can do that, definitely the research and development and the innovation and industrial technological innovation and the management we could do, definitely. The action research is very, very much important. Funding research, we are talking about funding. Professor Nawaz said the significant number of percentage of the national GDP has been allocated for US R&D. But what about us? But what about the developing countries like us? It's very, very less. So all these things to be put together to become successful through innovation. Without innovation, there is no way to become getting a sustainable economic development. We could develop, we could do many things, but once it would become very frustrating for us, that development will be very frustrating for us. You know that in Dhaka city, many things we have to change. because of not doing proper planning. Without proper planning, if we do development, then after 20 years, 30 years, 50 years, it will become what is called, that is problematic for us. So that's all. And then finally, I would like to say one quotation he draw, depending on his long years teaching and research experience, especially industrial research experience, which is very, seemed to me very interesting. Technology is a game for the rich, a dream for the poor, and a key for the wise. Technological innovation is the master key for sustainability. Through industries globalization, in the current competitive world setting, which is now we are telling fourth industrial revolution. So in this fourth industrial revolution, what we are now, are we rich or are we poor or are we wise? That is the question, and that question should be answered from the policymaker, should be answered from the researcher and the top level organization. And only then we can be thinking of the sustainable economic development of Bangladesh. And the final word, he said that the master key for, it's not only key, we always tell key to success, but master key to success is a new term I heard today. It's very related and very important. So we need a master key so that we can have for our nation a sustainable economic development. And thank you so much. I don't want to prolong my speech more because it's now almost close to 10. Thank you once again, Professor Dr. Nawaz Sharif, and definitely the participants and the organizers. The team of CDC has done a tremendous job, and definitely Professor Nawaz Sharif. Thank you so much. Thank you all. Bye-bye.
Thank you. Oh.
Assalamu alaikum, sir. Hello, Dagun, sir.
So thank you, everyone. Good evening, good night. Take care. Take care of your health as well. And thank you for joining with us. And thank you for your patience. Thank you, respected participants and honorable presenter of this conference, Professor Dr. Nawaz Sharif, sir. Thank you.